Hello and welcome to this guide using Logic's new DeEsser 2 found in 10.4.5. So Apple recently updated the Logic software, and with that came the new DeEsser 2. And in this video I'm going to take you through what all the dials and functions mean. I will also demonstrate how to DeEss a vocal, and beyond that we're also going to look at how you can use a DeEsser to create interesting sounds when you're using synthesizers or drums or sound design, that type of thing as well. But first of all, let's take a look at the DeEsser 2. If you're not familiar with how a DeEsser works, I'm going to go through this now and demonstrate it for you. Alright, this is a long video on a DeEsser, but you're not going to want to miss it because there is a whole ton of stuff on the DeEsser. It's going to supercharge your understanding of how to use the DeEsser 2 and when is the right time to use it. Now, the video that I'm going to do on the advanced techniques using a DeEsser for sound design, that's going to come in a different video. So hit the like and subscribe button now and the bell button as well so that you don't miss that video when it comes out. You're not going to want to miss it because there's loads of really cool ideas that I'm going to give you there. Anyway, on with the show. What is a DeEsser? Well, it's basically used to eliminate sibilant sounds, overly emphasized S sounds, especially in vocals, and plosive sounds such as T's that can be emphasized by a compressor or saturation effects from the signal chain. So what's different about the DeEsser 2 in relation to the original DeEsser? The DeEsser 2 compresses the signal dynamically, preventing the sound from becoming darker when no sibilants is present. So an issue with DeEssers is they can make a vocal sound darker when compressing the high end. Now this plugin is aiming to eliminate that by working more dynamically. I think if you go over the top with the settings, you're still going to be able to make a vocal darker. Of course, it's all dependent on how you set everything up. So another point about this is the DeEsser 2 has extremely fast attack and release response times for the shortest transients, thus retaining a natural sound. I'm assuming then that in the original DeEsser, the attack times needed tweaking. Also, the DeEsser 2 provides two operating modes that enable you to work with high or low energy signals. This is where this mode is the biggest change between the DeEsser 1 and the DeEsser 2. And I'm going to talk about absolute and relative modes later on in the video. So also included are two filter shapes, a range of parameters that are used to define and control the affected frequencies. So let's actually first of all go through the various parameters and talk about what each one does. So the first thing is, let's go from the left hand side to the right hand side. You can see that you've got your detection meter, which shows you the level of the incoming signal, and the incoming signal is displayed through the meter here and also with the numerical number at the top.
So get out and stay out.
So you can see there that we've got a level coming in here, but we also get the exact numerical data at the top. This can be clicked to reset. You also have this slider, and this you can see corresponds to the threshold level, and the threshold level is used to set the amount of processing that's going to take place. Now it's probably a good point at this moment in time to show you how the meters work. If I hit play and I'm in absolute mode, you can see
get out and stay out.
That I get this blue level bar. So if I bring this down to 27.5,
so get out and stay out. I finally had enough.
So now if I pull it down further, what will happen is when the level passes this threshold line, you'll see it will turn yellow.
So get out and stay out. I finally had enough.
So you can see as it passes the line, it goes yellow. That means the DeEsser is actually now doing something. And that leads us to the reduction meter. Now, at the moment, I've got this set to 0, so it means that no reduction will take place. But if I just pull this all the way down, I'm going to show you that you'll get a reduction level here.
So get out and stay out.
And you can see now that this is actually working and reducing the level that I've set. So you have a detection meter that you can set the threshold with. You also have a reduction meter that will show you how much reduction is taking place. But what's great about this is that the reduction meter can be set to have a maximum amount of reduction. And you can see as I turn this dial here, the slider moves correspondingly as well. So what does the reduction meter do? Well, if I set this to -60, however much this signal goes over my threshold level, you'll get an equal amount of reduction down here, okay, on the reduction meter.
So get out and stay out. I finally had enough. Don't.
So you can see there that we've got, this is 60 to 30. This is 30 decibels of gain coming in because I've got this set all the way down. So it's no surprising then that the reduction meter is giving me an equal amount of gain reduction. Now that may be fine in some cases, but in other instances you may not want that much gain reduction. So I can set the maximum reduction to, let's say for example, 5 dBs.
So get out and stay out.
So it's just blocking this completely, but it's not going beyond 5 decibels. Okay, so let's move on. I'll keep this here. The frequency dial allows you to find the frequency that you're looking to remove. So if it's an S, for example, S's can be found anywhere from 3K or 6K or 9K, depending on what type of frequency it is that you're trying to get rid of. Quite often the frequency is actually lower than you think it is. If it's a very sibilant sound that's tearing your ears off, the likelihood is that it's, you know, in the upper frequency range. If it's a sound that is just s like that and it's too loud in the mix, maybe that's come about because you've compressed the signal to get everything nice and even, and those s sounds have come up too much. Well, you'll likely find them somewhere between 5K and 6K, and even lower down. Now, if you are de-essing lower down, you have to be really careful because, of course, there's a lot of vocal energy from other vocal parts if you're using a vocal, for example. And this is where the maximum reduction can be really useful because you could actually de-ess the S's, but at the same time the rest of the vocal is also being de-essed as well. And if the maximum reduction is too much, then you're just going to wreck your vocal. Okay, so I'm going to leave mode for the moment. I'm going to come back to this. Okay, so we have split and wide for the range, and we also have a filter mode here that you can see. And this is a shelf and then a bell curve. So let me show you what is really going on here. So if you have it in split mode, let's say that you set your frequency at 3000 Hertz. So let's just put this to 3000 here. Now, I don't know what the actual curve is, but we're in split mode. The amount of width, the Q factor, is going to be much less. So you can see it could well be here. So as the compressor is working and turning down, it's going to continually turn down in a narrow band. In wide mode, when you're in a bell curve, the width is much greater and it will compress your signal over a broader range. You know, it could be something like this, for example. And this can be useful because, as I said a second ago, when you're de-essing a part, if you have a sibilant sound that is here, for example, and then another sibilant sound, that sibilant sound also is an octave above, you could have two sibilant points. So by de-essing it over a wider region, you could pull this one down the most, for example, and then that bell curve will also pull this one down a little bit as well. If we set the shelf up at 3K, what a shelf is going to do, of course, is it's going to turn the music or the program part that you've got, it's going to turn the part down like this. One thing you have to be careful with the filter curve is that if you see here, I'm DeEssing at 3K, I'm also pulling down sounds that are before the 3K point. So it's often useful to find the frequency that you want to turn down and then play around with moving the shelf backwards and forwards with the frequency dial to find the perfect spot. Because if you see here, for example, if I put it just ahead of where I want it to be, I'm going to DeEss this less than the actual main reduction point, which would be over here. So it's important to remember with a shelf, it's going to work in a completely different way to the bell curve. So why have a shelf? Well, again, if you have sibilant sounds that when the S is sung, the S is sibilant here, here, and here, well, what the shelf will do, of course, is pull all three down. Okay, so in wide mode, when we go to wide mode, well, you're widening again the area at which the gain reduction takes place. So it will actually DeEss over a broader spectrum than when it's in split mode. And that's why it's important to set your threshold correctly, so you're trying to bring down just the things that you want to, the T's, the S's, that type of thing, if we're trying to DeEss. Okay, so one of the things that I want to show you now is what impact the DeEsser will have on the frequency range. So you can actually see and visually understand what's going on with the DeEsser, and also it'll give you some kind of idea of the width of the filter types. Now all I'm going to do is show you what the curve looks like. So I'm starting off with the bell curve, and I'm just simply going to turn the threshold down. You might be able to hear the pink noise has changed. That 1.2K area has now got a hole in it, and here you can see, here's the bell curve. Now if you notice, it drops down and to this very narrow point here at 1.2. So let's take a look at the shelf and see what that looks like. So now with the shelf, you can see that it starts to roll off a little bit before your fixed frequency point. Wherever you set this frequency at, the roll off will begin just before it. And also notice that it takes some distance before it drops right to its maximum level. And then notice, just like on a normal shelf in an EQ where you can adjust the Q factor, there's a bump, it comes back up slightly. Now I don't think this is 100% accurate, but when you put it on wide, you can see it's dropping everything here. Now I don't think that's actually the case. I don't think it's going to drop everything, but it does show you that there's quite a wide range on the wide range type that you can add, even across the bell curve and the shelf. Okay, finally, the last part of the plugin, the filter solo mode. Now what this does is this allows you to fine-tune the frequency that you're looking for. So for example, in this case with this vocal, where I've compressed this, I've essentially brought out the T's and S's even more. I've highlighted them because I've compressed this quite hard. Now I need to use a DeEsser to pull those things down. I want to find the T's and the S's that I've brought out too much with the compressor. So what I can do is I can put it in filter solo mode, and what we'll hear is just the frequency area as I slide around. So for example, if we start at 1200 Hertz, as I move the frequency dial up and down, so it allows you to highlight just the one area until you find the exact spot that you're looking for.
So get out and stay out. I finally had enough. So get out and stay.
So you can hear at 3000, the T is very prominent.
So get out and
now I'm going to double this and go up the octave. Let's see.
So get out and
so you can see around here the T is very prominent. And let's go again, double it again.
So get out and stay out. So get out and
so that T there at the upper frequency range at 12,000 Hertz is not really much of a big deal. It's not particularly loud. It's not particularly cutting on the ear. So it's going to be, I'm going to reduce either 6,000 or 3,000. And the way I was able to do that was to actually use the filter in solo mode. Then once I've found the frequency that I'm looking for, the frequency that I want to reduce, I can switch it to off, and then I can actually start to do the process of DeEssing. There is another way that you can do this, and that's using the analyzer.
So get out and stay out.
And you can see on those T's, have a look again, around here there's a big peak on the T and the S's.
So get out and stay.
So I know straight away that somewhere around here there is a peak on those sibilant sounds.
So get out and stay.
And it also peaks up around here as well. And that's also a useful way of doing it. Sometimes it can be really difficult to just use the frequency dial and dial it in. So let's move on. Let's actually DeEss this vocal and see how it works. Now I'm going to demonstrate the modes now. So I'm going to start off in absolute mode. Absolute mode is based on volume. That's really what the DeEsser does. It looks at the incoming volume and then works out how much reduction should be applied based on the frequency that you set and the threshold level that you determine. I'm not going to get too bogged down in the precise number. I'm just going to set it around 6,000 and see what happens.
So get out and stay out.
Okay, so you can see here that we're peaking around somewhere around -30. So I'm going to bring this down to about 40 and see what happens.
So get out and stay out. I finally had enough.
So you can see when she sings "I've finally had enough," there's no sibilant or plosive sounds that I want to remove there. So what the DeEsser is doing is it's just seeing all of that material. I'm going to bring this up a little bit and see what happens.
So get out and stay.
So there you can see the two plosive T sounds are DeEssed.
So get out and stay.
But the rest of the vocal, I think, is probably going to be DeEssed too.
So get out and stay out. I finally had enough. Don't kiss me on your way out. It will.
So you can see there's too much DeEssing going on. But I have to say, I think this is pretty good. What's different about the DeEsser 2? DeEsser 2 compresses the signal dynamically, preventing the sound from becoming darker when no sibilance is present. So I think that is actually the case here.
So get out and stay out.
Let's switch it off.
So get out and stay out. I finally had it. So get out and stay out.
So I could go further with this on those T's.
So get out and stay out.
And decide that I only want to DeEss this by, let's say, around 4 dBs.
So get out and stay out. I finally had enough. Don't.
So here's a good example of how I've set this up with the maximum reduction. I'm removing or reducing the T's and the S's, but when she's singing the other lyrics in the song where there's not sounds that I want to reduce, by having this maximum reduction at -4.3, I can get away with other parts of the vocal being pulled down in this frequency area by 4 dBs, and it's not destroying the vocal. So let's do this in filter mode.
So get out and stay out.
So straight away you can hear this is actually making the vocals sound darker because I'm actually filtering it with a shelf. So it's pulling everything down. And I've also reduced it to 3K, which is where the vocal presence is.
So get out and...
So that, of course, is way too much. There's two things that I can do. Bring the threshold level up.
So get out and stay out.
So you see there I'm catching the T's and not catching other elements of the vocal.
So get out and stay out. I finally had enough. Don't kiss.
Now this is much more gentle on the mix. I'm getting less gain reduction, but I could also set this just as a safety net.
So get out and stay out. I finally had enough. Don't kiss me on your way out.
So you see on kiss, it catches. I could pull it down if I wanted to. It's all about a balance between where you want things to sound. All right, let's take a look at wide mode in the shelf.
So get out and stay out.
Let's pull it down so you can hear it as an example.
So get out and stay out. I finally had enough. Don't.
You can actually hear this working almost as a compressor now. Because it's over a wider frequency range, it's pulling everything down as opposed to just this area here, 3.5K and above. So with the wide range, you have to be very careful how you set it. You have to be much more subtle.
So get out and stay out. I finally had enough. Don't.
So that's much better. I could go even less than that.
So get out and stay.
And you see I'm catching the T's. And I'm going to set this at, because in wide mode, it's pulling everything down. I'm going to set my maximum reduction to less than what I did before because the effect is more obvious, so I want to reduce the amount of reduction that could possibly take place.
So get out and stay out.
And then I can fine-tune this.
So get out and stay out.
And that's better. So it's all about a balance. Listen to the vocal part, listen to what's happening to the vocal, and then A-B it.
So get out and so get out and
Can you hear those top end T's coming back in, the higher frequencies?
So get out
and listen to how they're slightly reduced.
So get out and stay.
Just pulls it back a little bit. Now, I'm doing this as a vocal that's soloed. What I would normally do if it was in the context of a mix is I'll probably do this with the entire mix playing, and that way I can hear if I'm burying my vocal back into the music or doing the job that the DeEsser is supposed to do, which is taking plosive sounds away, T's, plosive T's or S's. It's reducing those a little bit because I've compressed the vocal hard or because the singer or the microphone was very bright. That's essentially how you set everything up in absolute mode. Let's now look at relative mode. So in absolute mode, as we've already discussed, it's based on the incoming volume signal that you see on your detection meter. So basically what that means is this: if I play the vocal,
so get out and stay,
you can see that I'm getting a level that is peaking almost around minus 30 dBs. But what happens is, let's say, for example, let's go extreme. Let's say you want to go back to the compressor and rework some settings on your compressor, and the compressor is before the DeEsser. So when you reset compression settings, you're ultimately going to change the volume, and that can affect what the DeEsser is doing. So let's go extreme. What I'm going to do, play the vocal, and I'm going to turn the output level all the way down.
So get out and stay out. I finally had enough. Don't.
You can see it illustrates the point. I'm no longer de-essing anything. I need to turn this all the way down to 60, minus 60, for it to actually do anything. And now, of course, because I've turned it all the way down, I don't know what I'm really de-essing. You know, it's not doing the job that I originally intended to. So in absolute mode, unless you're going to stick to the absolute same volume, you could actually end up with having to readjust the settings as you go, depending on what you do. So that's one of the downsides about absolute, and that's where relative mode can come in handy. Okay, so let's now look at relative, and I'm going to explain exactly what relative mode does. So I'm going to reset things. I'm going to put this down to maximum reduction. When you're in relative mode, the DeEsser works in a completely different way to absolute, but ultimately you end up with a similar outcome. Relative mode, just like absolute, will determine the amount of gain reduction based on your settings. But the way relative works it out is based on frequency as opposed to volume. So relative mode looks at the frequency of your material rather than the incoming volume. So if we look at the manual, in this mode, the energy level of the band high pass signal determined by the frequency, so determined by the frequency knob, and filter settings, so this section here, is compared with the full bandwidth energy level of the incoming signal. So basically what that means is whatever frequency you set here, so for example in this case 3.5K, it compares this frequency level with the energy level of the entire bandwidth. So if we look at the channel EQ, I can explain this more clearly. If I set this at 3.5K, you can see that the energy level here on this peak is, plus 15 dBs. But what relative mode will do is it will look at the values, the energy level of the frequency across the full bandwidth of everything else. So it's going to compare this section with everything here, and that will then determine the amount of gain reduction that's needed to be applied, or whether indeed any gain reduction needs to be applied at all. So it's looking at frequency as opposed to volume. So the way the DeEsser works is slightly different in relative mode to absolute. Now, when you're in relative mode, it works in a completely different way. Essentially, when you're in relative mode, when you're at 0 dB, the DeEsser isn't going to do anything. You've basically switched it off.
So get out and stay out. I finally had enough. Don't.
So you can see that this level, the blue bar now moving down as opposed to up, is actually the DeEsser analyzing the relationship between the frequency that I've set and the full band, the energy of the full bandwidth. Now, as I pull this down, the blue line will turn into a yellow line, and that will then give me the reduction that I need.
So get out and stay out. I finally had enough. Don't kiss me on your way out. It wouldn't move me much.
So you can see there, as I've pulled this down, I'm now starting to DeEss. So it's working in the same way as absolute mode, but the process is slightly different. And I'm going to show you why relative mode is a really good way to go as opposed to absolute. Now, the more I pull this down, just the same as in absolute mode, the more gain reduction I'm going to get.
So get out and stay out. So get out and stay out. I find.
So which should you choose, relative or absolute? Well, as I said before, if you use absolute and you know that you're not going to change the volume before the DeEsser, you'll always get the same result. In relative mode, because the DeEsser is looking at the frequency relationship between the band and high pass signal and the entire frequency range, it doesn't matter what I do to the level before the DeEsser. So watch this. So I've got this set at 0.
So get out and stay out. I finally had.
Okay, so you can see that we've got a lot of DeEssing going on. Let's do this again and be extreme. I'm going to turn this down to -30. So the volume, we know the volume is going to be around here. Watch what happens with the DeEsser.
So get out and stay out. I finally had enough. Don't.
It's still DeEssing the same amount as it does when the volume is up. And that's because it's no longer looking at the incoming volume into the DeEsser. It's looking at the relationship of the frequency that you have set compared to everything else and working out, well, how much should the DeEsser come down. And that is one of the biggest key new features in the DS2. I hope that makes sense and I've not confused you further, but just simply remember that absolute works on volume, the incoming volume into the DeEsser, whereas relative mode works on the relationship of the frequency that you set compared to the overall frequency of the entire spectrum of your sound. Wow, that was epically long for a DeEsser. Thank you so much if you've made it to the end of this video. I really do appreciate you taking the time to stick with me and listening to my meanderings and ramblings. I hope that you've got something out of this video, and I won't keep you any longer, but if you want me to keep making these videos, you know, give me that support, hit the like and subscribe button, and hopefully I'll see you soon. Cheers.